My name is Yahel from Airobotics, and the next 10 minutes I'll use to discuss a little bit and show you some applications of aerial data. Most of us have probably heard of drones, and we typically tend to look at the equipment and the vehicles, but rarely do you get to have a chance to see the actual data, and that's what I'm going to talk about today. I'll start from a bit of an observation about what was discussed in the last day and a half. And so it's very evident that mining is changing in the sense that the cost of acquisition of assets is higher, and it's really up to operators to be smarter and wiser about driving costs down. So clearly technology has a big role in play here, but you have to be smart about it. Much like previous speaker was saying, sometimes it's a case of just too much information, and or that there's too much effort going into collecting information, but then not enough clarity about what do you actually do with all that data in the end. And so for us, for robotics, we at least started by trying to solve the collection problem. Right? Drones really came about and been adopted for the last 10 years by surveyors, and it solved an interesting problem of collection, where the collection activity itself was what you call a dull, dirty, dangerous job. However, by turning surveyors into pilots, we really only changed the collection method. They're still doing a dull job, and they're still spending too much time actually collecting the information, not enough time analyzing and processing. So for us at Airobotics, we recognize that there's a big value here by automating the collection point. And by automating, we lend ourselves to a few applications. So security, emergency response, inspection, and mapping. I don't have enough time to cover everything, so I'm going to focus on survey and mapping and try to give everyone a taste of what does it mean to have an automated collection utility on site that's picking information all the time, and how are sites using it to their advantage. So what you see here is a day of LiDAR collection at site, and you'll notice that it's not that we scan the entire site. We only care about those areas that are active mining areas where things are changing frequently. It's important to say that mission planning is critical, so in order to be effective, we want to go to those active area mines. So, for example, you can look at the top right, and we'd fly over to do a bench before blast. On the way back, we'll fly through a whole road and just collect that extra piece of information. All this automation really lends to one thing, and that is frequency. So at some of our sites, we fly 70 times a week. That's an enormous amount of information. And we came to a problem at some point of what do you do with all this information? Who's analyzing it? Who's processing it? And how does it impact the bottom line of the business? So I can share with you one little cool application we've recently gotten onto that has to do with monitoring scrapers and dozers while they're working. So at any sites that you may see, you can ask around how often does a surveyor come to take a pickup of dozer working randomly on a stockpile, reclaiming it. And typically the answer will be once a month. We here started monitoring dozer activity. We brought the pickup from once a month to every other week, then every week, then every other day. And what we saw is that there's a correlation between the amount of information you supply to operators and the end-of cost of moving earth. And so at this one particular location, we're able to drop the cost from $24 a meter squared to $12 a meter squared. And the reason for that is that the people who are actually actively working on the dozers all of a sudden have a map to show what they did today, what they did yesterday, what was the difference, and most importantly, in which areas are they off the plan. And so when you give somebody an indication they've made a mistake, you give it to them the day after or the next day versus a month later. And all of a sudden, all this free time is going to be cleared up because you're not going to be working for a week correcting past month's mistakes. Moving on to stockpile. So this is very low-hanging fruit. Surveyors started doing stockpile measurements with drones, again, maybe 10 years ago. However, for us, frequency is key. So we thought about it. It's an automated system. You're already flying. There's no marginal cost to measuring extra data. So why reconcile once a month when you can reconcile every week or every other day? If you can do that, you're turning an accounting problem of reconciliation into an operational insight. All of a sudden, we know what's in our ROM pads, what's been added from yesterday to today. And that really gives an indication to how well did we mine today or yesterday. And once you keep repeatedly measuring over time, you end up seeing trends. You can correlate environmental factors. You can start doing some predictive work. And that really is where the interesting stuff's at. Here's another little cool application we've recently done. So this is a ROM pad that we measure every day. And if you can see on the top left corner, we focused in on a corner. So this is in Australia, left-hand drive, and you can see that internal corner is a little bumpy. We put a little cross-section mark on it. We wanted to see what it looks like. Clearly, we saw that it was suboptimal. The mine brought a dozer in just to level it out. And when you look at the cross-section, you really start to understand what the truck feels like as it's driving through that corner. So you can appreciate the impact this has both on the maintenance cost of a vehicle, on the speed at which it can travel, and of course the safety of the driver delivering. Now if you can do that on one corner, can you do it on an entire road? Or better yet, can you do it on every road in the mine, and can you do that every week or every day? So the answer is yes, you can do that. We use LiDAR and we use algorithms in order to generate some business insight for road management. And what we try to focus in is delivering data that is not complex. So delivering something the superintendent can digest visually without having any engineering knowledge. And here's one example of color-coded map of a whole road. Every spot that's not wide enough is marked in red. And so you don't need an engineer to help you sift through this and understand this is very digestible. You can hand it to the ground crews and they'll know what to do. You can do the same looking at super elevation and looking at which areas of the road do not support the whole truck driving at optimal speed. You can do that for safety barriers and looking at which areas of the road do not comply to the plan and will not support or not pass a safety inspection. And you can do that all over the mine. Every single week you can get a snapshot of, are we good or do we need to fix something? Two more examples, and one of them has to do with predicted for water. And you can see where water is going to be pooling, and you can see where water is going to be flowing into. And of course, water flowing across the road is not a good thing. Why wait till after you have a crease in a road when you can get the data before and you can do some predictive analysis and you can know which areas are going to be of the road are going to be damaged the next time it rains over an inch or two. We came across, and this is the last example before I'm done. So we came across an interesting issue that have to do with schedulers. They did not have a very efficient way to get data and get feedback from the ground about what's being developed. So any mine that's going through a development phase, building a whole road or expanding a pit or whatnot, today the flow of information goes from the superintendent to the supervisor to the scheduler, and it's all hearsay. You hardly ever hear of a superintendent who will volunteer and say, I'm late on my project. So they're always on time, but what they're not going to say is, are they or they're not to spec of the plan. And so what we do is we present a very, again, easily digestible map, a heat map, if you will, for our on design, off design, and this is something the crews on the ground can use by themselves without any engineering assistance and improve their day-to-day performance. That's it. We don't have any time for questions. The guys are pushing me off, but if you have any questions, you can come see us. We're just sitting at the back. Thanks.